Welcome to our deep dive into the world of rust. You know that reddish-brown stuff that seems to pop up on metal like an unwelcome guest? We're going to break it down, get to the nitty-gritty and explore what rust really is. Believe it or not, rust is more than just one thing. Oh no, my friends, there are different types of rust, each with its own unique properties and ways of forming. Get ready, because today we'll explore the hows and whys of rust formation and the different forms this fascinating phenomenon can take. Let's start with the basics. Red rust. This is the type of rust we most commonly encounter. You know, the one that gives abandoned cars that classic rusty look. Chemically, red rust is iron 3 oxide, or FeO3NH2O. For red rust, you need iron and water. And don't forget oxygen. Rust forms through oxidation. Iron and oxygen bond, creating rust. Next up, we've got yellow rust, also known as iron oxide hydroxide. As its name suggests, this type of rust loves moisture. You'll often find it in damp enclosed spaces, like inside pipes or under peeling paint. Yellow rust has a yellowish-brown hue and a different chemical composition than red rust, FeO2O. It forms when iron is exposed to high moisture but limited oxygen. This results in the formation of yellow rust. Now we're getting into some serious rust business with black rust. This type of rust, scientifically known as iron 2,3 oxide, Fe3O4, is sneakier than its reddish cousins. It forms in low oxygen environments, often underwater or underground. Think of old shipwrecks or underwater pipelines. It's a slow force, weakening iron and steel over time. Interestingly, black rust can act as a protective barrier. Now let's talk about white rust. This one's a bit different because it doesn't directly involve iron. Instead, white rust, with its chemical formula of ZNO, targets galvanized steel. See, galvanized steel is coated with a layer of zinc to protect it from rust. But even zinc can fall victim to corrosion, especially in the presence of moisture, carbon dioxide, and certain chemicals. When this happens, you get a white or greyish powdery substance on the surface of the steel. That's white rust. Hold on to your hats, folks, because things are about to get a little more complex with green rust. This type of rust, chemically known as iron 2 hydroxide, is a bit of a rarity. It forms under very specific conditions, high levels of carbon dioxide and low levels of oxygen. Think of environments like stagnant water or waterlogged soils. Green rust has a distinctive greenish-grey colour and is often found in association with bacteria. In fact, some types of bacteria can actually promote the formation of green rust. Now, let's dive into the world of purple rust, also known as iron 3 phosphate. This type of rust is a bit of a specialist, preferring environments rich in phosphates. You'll often find purple rust in marine environments or near agricultural areas where phosphate-containing fertilizers are used. It has a distinctive purplish-brown color and can form on both iron and steel. Purple rust is particularly problematic because it can be quite adhesive and difficult to remove. And last but not least, we come to blue rust. Now this one's a bit of a trickster because it doesn't even involve iron. Blue rust, chemically known as copper sulfate pentahydrate, forms on copper and copper alloys. Think of those beautiful copper statues you see in parks or the copper pipes in your home. When copper is exposed to oxygen, water and sulfur compounds, it can develop a blue-green patina. That's blue rust. While it might not be as structurally damaging as some other types of rust, it can still weaken copper over time and affect its appearance. And there you have it, the colourful and complex world of rust. By understanding these different types, we can better protect our iron and steel structures from corrosion. Remember, rust is a natural process, but by understanding the science behind it, we can take steps to prevent it or slow it down. From red rust to blue rust, each type has its own unique properties and ways of forming. But one thing's for sure, rust is a fascinating example of the power of chemistry in action. Thanks for watching, and don't forget to like and subscribe for more fascinating science content.